Okay. All right. So, hey, welcome back. Part two here. Just tried live streaming this, but my internet is so abhorrent that it was dropping the live stream. So, I'm going to just kind of continue here. Some of these are going to be live stream if they work, and others will be videos, I suppose. All right, so hey, in the last video, if you're just coming into this one, you should really watch the intro, the very beginning of part one of this video series. It kind of explains what I'm doing and why the heck am I doing this in something like SketchUp of all things. Okay, well, the short answer, I'm going to make this real quick. I'm not going to repeat everything in the first video, but dudes down at the Maker Space where I volunteer and maintain the 3D printers at, they wanted to make, after they've seen the 3D printers that are brought down there for people to use, they wanted to make their own. They want to build their own. So we put together a little group on Wednesdays nights. They wanted to build the one that I designed, the MicroWrap 200. I kind of steered them away from that because mine isn't as popular as the Hypercube Evolution. I steered them towards the Hypercube Evolution because there's tons of remixes for it. So pretty much anybody who makes it's going to be really happy with being able to modify it. And that's really important when you're new. So now, why am I in SketchUp? Because before you can really modify things successfully, you have to have built one, right? I've never built the Hypercube Evolution, and I really need to model it. I need to see exactly millimeter for millimeter. Do things fit? Do these ideas and these changes that I'm going to make, do they actually fit? Are they going to work? That's the real question, right? And this takes out the guesswork. And the human brain, it's like with experience, meaning when we've touched or messed with something, we've had experience with it, the human brain can come up with some amazing stuff. I really believe that. So if I haven't built it in real life, building it virtually will actually help my brain, in my opinion, psychologically, I believe will help you imagine better ideas. Like new things will pop into your mind. And you know what? Guess what? How much does it cost to build stuff on here? Nothing. SketchUp's free. Now I'm using the pro version maybe, but the SketchUp is generally a free program. So, you know, even if you're not going to modify it, before you build a printer, and if you've never done one before, man, get into SketchUp. It's simple enough to learn, and watch video one. And it shows how I do a lot of the stuff that I've done up to this point. All right, so here we need to group together the Y-axis. I've already grouped this. I never did group, or excuse me, the X-axis. This deal here, so I'm going to grab this. Now, look, man, in this program, if you go left to right, it only selects the stuff that's all the way inside of your box. If you go right to left, it selects everything that's touching that box at all, or touching or inside of that box. So I'm going to do this. Component, sure. I'm pretty sure one of these is upside down, but I'll fix that later once we see the orientation of the motors. Okay, and we're going to make a component. Sure. We'll do that same left to right selection trick when we grab all of it together, make a component, and create this. Okay, so cool. So now we have this, and we can move this. If we lock it and press the left arrow, you can lock it on, and it can move as if it was just locked on that Y-axis. Another thing we can do later is we can, it's like, for example, this printer is going to have a travel of 300 millimeters to print. And what we can do is tap Control later on and check it out. You can type in, so that means it would move 150 forward. And you can see where that would go. And you can also see, for example, 150 back. Where would that go? And then later we'll get into here, because it's a component, they're all updated dynamically when changes happen to one of them. We're going to do the same thing here. Let's go 150 on the red axis. And 150 on the red axis this way. So you get to, basically, you can see like the printing extents of like where's the farthest it's going to go. Okay, I'm getting ahead of myself though. Let's not do this. Let's just keep it simple. Get back in the group. Okay. And let's go ahead and start importing some more stuff here. So I'm going to import, and hey, it actually has the same files that I used in, say, VA1. It's kind of just sets me right there. All right, so what I need to do is let's get the stepper motor. And on this printer, the stepper motors are mounted in the front. Let's see if I got it here. So yeah, you can see on this one, on this particular printer, the motors, you can see how abysmally, this is why I had to stop streaming earlier, because look how long it takes just to load a JPEG on my internet right now. So yeah, the motors are actually up front, and these idlers are in the rear. Okay. All right, so let's go ahead and grab a motor, and we have to make sure we grab the one that has the clamps for the 10mm rods, because there are two, I think there's two versions in here, if I'm not mistaken. Okay, here it is, XY stepper mount. Oh, I guess maybe that's incorrect. Oh, okay, here it is. Yeah, this is right. Okay, so we want the one that is not the one with diameter 8 in it. We want the XY, so 1.1 is the version number, so we probably want to stick with those. So it looks like for the right, this is the good one to get. There it is. Okay. Let's move that over. I think the midpoint of that should be lined up, but I don't know. We'll double check it later to see if I'm accurate with that. Perfect. Okay, that's lined up. Well, you know what? I need to get a parallel projection. Gets rid of that 3D view, that type of thing. All right, so front would be up here. Let's see, wait a minute. This should be up even with this, if I'm not mistaken. Yeah, that looks good. Now we need a front view. Again, another thing you should do is probably open up this and click view if you're going to use this program too much. It's very useful. I don't know if that's right on the money, but it's going to be close enough. Oh, that is not lined up at all. Whoops. I thought that would be at the midpoint. No, it isn't. Oh, it's looking pretty good. It's a little bit too low, I'd say. Well, that's not correct. It was better before. All right, you know, that's probably going to be close enough for what we're doing. Okay, so let's go back and import the next one. So that's going to hold a stepper motor. I mean, yeah, we're going to put in the stepper motors in a moment. So, because it's really easy to do with a 3D warehouse. So let's see, the motor XY stepper mount left. I do not see a 1.1 for left. Oh, wait. Yeah, I don't see a 1.1 for this version. Not for this. So, well, there's for the 8mm diameter. Okay, whatever. Good enough. This is a part probably I'm not even going to use once we CNC remix this. Because all it's doing is holding the rod, and you know the intention of the front part of the chassis that we're going to cut out of the CNC machine can certainly do that probably very accurately. You know, you can cut, CNC machines cut very accurately. So okay, this we don't want to line up that way. We learned that last time the hard way. Let's get the front view. That little line up there, by the way, that's actually in the center of this rod. It's kind of a guideline, so it's easy to line stuff up with it. All right, man, so let's go ahead and get a front view again. And let's find out. What we're looking for is actually the very farthest out point. I think it's right. Yeah, that might be it. If not, we'll find out. Oh, that looks really good. You know, I didn't do it by... All right. Okay, cool. That should be good. Let's get the idlers, which are on the back, which will return the belts back. And then after that, I think we're going to start seeing why one of mine is screwed. One of mine is screwed up, it seems like. So, okay, so let's go File, and we'll import XY idler mount left. Yeah, 1.0. I think that's the newest one of those. So that was on the, see, the left-hand side. Yeah, that should be over here, as far as I can see. So let's, you know what? I'm going to try to see if we can just, actually, because these I think are identical on both sides, if I'm not mistaken, but we'll see. Let's just do it the official way, huh? The idler mount right, 1.1. There's a lot of stuff going on here, but I think that's the correct one. Yeah, XY idler mount 1.1. And I think these are just exact mirrors. Yeah, so whatever. But we can actually save a little bit of time because, you know, like we got to rotate both of them the same 90 degrees. Now let's think about it. This should be moved up against the frame exactly even with this rod. Yep. Yeah, okay, there we go. And, well, we could do the vertical adjustment. Those are going to be identical if they're lined up. Something like this. I don't know if this is correct, but we'll find out. Hey, and you know, if you see me doing something here, you think, man, this guy really doesn't know how to use SketchUp. Believe me, I can handle being humiliated, but it would really help me if you pointed out, you know. I'm not going to be humiliated by it, but my point is it would help me out if you commented on it. Like, hey, you're doing this repetitive nonsense. SketchUp makes it easier by X, Y, and Z. You should do this instead. Now let's see, is this 30 across? No, it's only 25. Okay. Well, whatever. Lock it on that x-axis, and I'm going to move it right over. Close enough. All right, cool. You know, another way we could probably align those is I bet you those should probably line up perfectly that way. But I'm not going to worry about it. I think that's probably sufficient for what we're doing. Okay, so now what do we need to do? We could add some motors. Let's do that. So I'm going to go to the 3D warehouse. Man, everybody's designing printers and CNC machines. There should be a NEMA 17. As a matter of fact, I know there is one in here. You got to check these because I have downloaded a NEMA 17 from here before that is absolutely incorrect. Like, just straight up the wrong dimensions. And so that, you know, hey, what's this? Does this have a 20 tooth? That might actually be good enough for what we're doing. It doesn't really say. Guess not. Let's go back and just grab one because I'm not sure if that's going to suffice for our pulley. I'll probably just put some nonsense on there for the pulley anyhow, just some to fill in. Let's see. What's this guy look like? That looks pretty good. Yep, put it right in there. All right. So before we infect our drawing with this thing, let's make sure it's quarantined and not quarantined, but you know what I mean. Just joking around. All right, so let's see. This should be 31. Hey, it's 31. And that's correct at 42. All right, so that's it. Either way, this is, if it's not exact, it's close enough. And, you know, I might want to use a 48 millimeter stepper for this. This looks like a 40 millimeter, just to kind of cover all the bases. Like, it's a little longer. Let me see here. Yeah, so that's about 40 millimeters. I think I'm going to do, just move this down 4. Move this down. Whoops. Move the combination of them the two down 4. It's a magical stepper motor. Stuff's floating in there. Good God, how did they make this model? There we go. Okay, it screwed up the colors completely, but whatever. That's a great looking stepper motor with that white bands that I've added to it. I feel like all stepper motors should be that way. Whoops. Let's get out of the group first and start moving this thing around. All right, so now we're going to line this up the midpoint here. Let's get a straight on top view. Something like that. And locking on the Y-axis. I think I've already planed it up on the right level for Z. That looks pretty good. All right, so cool. There it is. We've got our first stepper motor on there. Let's go ahead and take this guy and copy it over here. Oh, wait, actually, let me see if they have GT2 pulleys in here. I don't see why they wouldn't. GT2 pulley. Oh yeah, man, there's lots of them. 20 tooth, 8mm. Yeah, that is usually what they are. It's 6mm belt, but they give you like a millimeter on either side. That sounds pretty good. Yeah, we're going to put that right in the model. And again, hoping it's correct. I'm just going to kind of hope. Ah, I see. It's 8mm on for the shaft. But what's the difference, really? Why did I not do that? Oh, I have to click it to place it. I see. So it's made for an 8mm shaft. That's whatever. So it won't have the right shaft size. But who cares, right? Like, it's going to be centered and it's going to be correct, so that's fine. And let's go ahead and this is the part that I think I'm going to have to change some things around. Okay, so let's copy these guys, make a component, or actually make a, let's make a component, we'll make them unique later. Because one of them is going to have a pulley flipped upside down if I remember right. Let's take this and grab it, lock it on the red axis, so that shouldn't be any different. Top view would be nifty. All right. Cool. All right, so here's my point. So one of these has got to be, one of these is incorrect. And it's got to be flipped. So let's see. Let's take a look at Scott 3D's Hypercube Evolution page. Let's see if we can see a view. Okay, so it looks on the left side of the printer over here. That one has has the pulley up, and this one is pulley upside down. So it's down on the right, up, left, down, right. Okay, up on the left. So this one has got to change. Let's actually do our rotation here. Get in here. Whoops, we need to make it unique. There we go. Oh, I see. I didn't. No, it's cool. Got it. All right. Lock it on the, yeah, the Y-axis. There we go. I'm going to flip this baby upside down. $180. All right, that should do it. All right, now let's take a look here. This one, so if we look here from the front, I'm going to move this out of the way, 100mm. All right, so if we look at this one, this should be driving and then going Yeah, this is not correct. Let's see this one. You have to bear with me on this because I'm not an expert on this printer. I've never made one. So this is why we do it, I guess, huh? Yeah, now this is what looks correct. So I'm going to adjust that until the middle of this is even with the middle of this other one. You can reference the midpoints. Okay, so I like that. That looks correct, and the belt would wrap around there and return through the loop. Okay. So this thing needs to have this little gap flipped to the top, as far as I can tell. And maybe I'm wrong about that, but okay. Is it a flip? No. So rotate. How do we do this? Oh, easy. There we go. Midpoint reference. Midpoint reference. Let's see if I can get this to work. Midpoint. No. Oh, I see. It's referencing that stupid thing. Let's try this again. Ugh. There it goes. And we are going to rotate it 180. There it is. That's, I think, what we want. Let's take a look. Yeah. We do need to get a front view and make sure that is correct. And this is basically, you're actually seeing one of, when you see this, you're actually getting an insight into one of the weaknesses of Core XY. I don't want to say weakness, but like complex belt path, right? This is way harder than traditional Cartesian printers. But it's not that big of a deal, right? Okay, cool. So we have that all ready to go. I am officially not done with the Y-axis yet. Sorry. What we're going to do is we're going to bust into here, copy one of these idlers that I made. You know what? I'll bet you money. I'll bet you they have a real one in here. Let's see if they do. 20-tooth idler. GT2 idler. Okay, well, but that's not much better than my model, so whatever. Okay, cool. So we'll just use this. So let's paste that copy that we made. And for this one, I am going to, let's take a look here. For aligning stuff on things like this, you know, it appears that might be the center. We'll find out right now. No, we won't. Okay, so this, from the back view, this should align with this idler right here. So we're going to grab middle to middle. That should do it. And we need another copy. So let's go grab it, lock on the blue axis, and go down here until it's even with this belt path middle, which would be right here, referencing that pass through. Grab the two of these. Let's get ourselves a top view. Make sure that that looks good. You know, like I said, this is a very detail-oriented hobby, so it's not a bad thing to take time and make sure it's actually absolutely correct. Getting in that habit, I feel like, man, I feel like it really, in the long run, it definitely saves time. Let's grab both of those. Make a copy. Okay, cool. So we're done with that. You know, we could put in more. I just said to be detail already, but I don't think I'm going to be modeling the screws for this. So, because actually, you know, in reality, these parts are going to be swapped out. All of this is like these pieces here, this, and this. I don't know. These might be different. These are either going to be different or wood. They're going to be wood or whatever material we're cutting on the CNC machine when I actually get it ready. Okay, cool. So let's go on to the next part here, and that is the 30-30 frame. I'm probably not going to get this 100% accurate right now because we're going to adjust it once we add the Z-axis later, but we can definitely get it pretty good for the X and Y axis. So let's take a look. How am I going to do the 30-30? Well, I'm going to actually sketch it. Let's get a top view. I'll just do it from the top here, I suppose. And we're going to draw a rectangle. And 30, 30. And, you know, I'm not going to model it exactly, but I do know a few things about this 30-30 extrusion. Well, we can look up some dimensions just to make it look a little cooler than whatever. So 30-30 aluminum profile dimensions. Yeah. All right, so it looks like there's probably a lot of different versions of the, yeah, I mean, completely different versions. You know, let's just, what we really need to see is kind of, I just want to see how much it was rounded off. What's the fillet on there? Oh, okay, here's one that kind of gives you an idea. So they're saying a radius of 3 there. Depth of 9.6. And the gap of 8. And yeah. So let's just do kind of a basic version of that. We could definitely do the radius. I want to make a line. 3, 3, arc. And I'm going to rotate that sucker. Q. Grab the arc. Reference midpoint. There it is. Reference them both, and now we're going to rotate that. Press Control to make it a copy, 90. And then without moving anything or touching anything, you press the star, which is multiplied by, I think 3. Okay, cool. So there's our copies of those. And we're just going to put a notch here. So from the midpoint, it would be over 4, because this was a gap of 8. I would go down 9.6. I'm gonna, like I said, this is gonna kind of be a rough version, over 8 and straight up. These guys we will rotate in the same manner. So I'm gonna press Q, midpoint, midpoint. Control to make it a copy, 90, star, 3 copies. Cool. And that looks good. Or at least, you know, it's kind of good. It's not perfect. It's not exactly what aluminum extrusion's like. But you know what? For just looking at it in the model before I delete it later to replace it, yeah, I think that will work. And now we can, you know, we can make this, whoops. We can just extrude it as long as we want. Oh, how big was that circle in the middle? Let's just put that. I mean, just 6.8. Okay, 6.8. Okay, 6.8 makes sense because I think you tap it with M8. That might be the tap. We're pretty close to it. Which 6.75 should be, I think, the tap size for an M8. So let's go 6.8. Whoops. Sometimes it's, oh man. Yeah, so we have half of that, so 3.4. Because it's the radius in this program. It's annoying. All right, man, that, you know, that's going to be good enough for mine, for my aluminum extrusions, because when we extrude it, you're not going to be able to see that that's actually not exactly right. All right, make a component, and we're going to move this into position. Well, let's make, since it's already going up and down, let's make this one first. That's lining, oh, that is not lining up right. Let's move it over on the x-axis. Yeah, okay. And 27.5, yeah, that looks about right. Okay, now let's take a look at Scott 3D's design. So he's using the vertical ones go all the way to the top, you know, just to do it right the way he's doing it. I mean, I'm sure there's other ways you can do this. So if it goes all the way to the top, I'm not sure if these are actually up against it. You know what? I'm going to move this up 30 just for the heck of it, because I think that's where it's going to end up. Again, I have no idea. Let's make this go down 500 for now. Who knows? We may have to shorten that later. They're components, so when we shorten one... Here's a problem with this program, by the way. Look at this, how it kind of glitches. See that? It's glitched out. When that happens, I don't know, man, maybe I'm doing something wrong, but I just switch it back and then... Oh, same problem. Yeah. So go to perspective, I guess. All right, so for this part, perspective should work okay, I guess. So let's move this over. So on this side, we'll be referencing this edge. Make a copy by clicking Control. Yeah, let's put that in position. It was about 499.98. You know what I'm going to do? I'm just going to be a rebel and make it 500. Because I'm crazy like that. Yeah. Don't think I won't. All right, so there's 500. Cool. That's great. I see. So the rod is actually centered at that, but this is just offset a bit. Okay, so it doesn't go all the way to the edge of this stuff. All right, we're going to need one in the back area, so that's going to be moved exactly 500 this way. Control, lock on the y-axis with the left arrow, and 500. Huh. 530 it should have been, because we have to take into account the... Okay, there we go. That looks good. Now what we're going to do is grab one of these, and we're going to rotate it. Save us some time, eh? 90. Before we do that, we want to make this one unique, so that the copies that come off of this, I'll move this down 30. No. Oh, I see. I didn't rotate it correctly, I guess, to do that. Let's move it up. And, whoops, I should not have referenced that part. Let's reference this instead. Ooh, cool. Well, I want to try this. I think this works, but I don't know. Top. So for these ones, I'm going to reference the origin. No. This might work. First I got to lock on this rotation. 90 star 3. All right, well, it kind of worked, I'm going to say. I'm going to give that a B minus. I'm going to delete this because this one's different. It needs to be made unique. Make a copy, 530. Yep. And we'll move it out here a bit. 50, whatever. And we'll push this. So I'm going to get in here and assemble this frame here. You'd have to really, I was starting to understand, this is get probably pretty monotonous to watch, so you'd really have to you'd have to really want to build a printer to watch through this series, I'd say. But that's cool, because I tell you what, when I was new at this, I would have loved to see something like this. Because I had no idea like how to tackle such a massive chore of taking on a printer. Or maybe it was that I didn't really want, maybe I could have imagined it, but maybe I was just such a lazy bum that I just wanted somebody, you know, spoon feed me or something. let's copy this. So basically what I'm saying is when I was new, maybe I may not have wanted to do the hard work that it takes to do something like this. Because, you know, it's not that hard though, really. I mean, I'm pretty decent with SketchUp. Like, I don't know all the tricks and things. Yeah, so anyways, kind of blabbing on. But what I'm saying is, I guess, is that when I was new, maybe I wouldn't have liked to imagine how much work this would be. But if you think about it, the first video was like 40 some minutes, but part of that was just like off time. This video wasn't super long, so, you know, in an hour and a half, I've made a pretty good chunk of this printer, which is cool because now we can do things and be very certain of what we're doing here. What I'm going to do now is I'm going to make, actually, in this video, to finish this on up, is I'm going to do some belt pathings to see if I could. I didn't do this the last time I tried this project. So basically what I'm going to do is I'm going to draw, bear with me on this, I'm going to draw from here, whoops, just so I can get a representation of what the belts are like in this machine. Bear with me. Let's try top view. Yep, there we go. Nope. Camera, parallel projection. All right. There it is. 472. Cool. Well, that's good to know, I guess. So let's go up 6 millimeters because GT2 belt is 6 millimeters thick, and we're gonna go back. Camera glitching. It usually glitches like that. I don't know why. But okay, and then GT2 belt. I don't know. Let's just go out. Let me think here. Past those teeth. 0.376 and 254. 0.376. Oh, actually, let's just do the past the effective diameter, which is 2.5. Yeah, it's 254. That's fine. So we'll just extrude this direction, 0.25, whatever. I know it looks thin, but that is actually after the effective diameter. Well, you know what? I'm actually going to put this other part on there that goes to the teeth, which would be an existing additional 376. It's 387. 0.37. I don't know. Whatever. Doesn't matter. I'll make that into a component. Create. And, you know, I could be adding colors to these things too. Personally, I'm colorblind, so you know, maybe that's not as important to me. But you can certainly do that if you'd like. I'll show you how to do that in a second here. But even for, I mean, to be honest though, even for somebody who's colorblind, it does help to see color, some coloring, you know, because you don't. It's not like we're living in a black and white movie here, bros. Okay, so let's take this to the midpoint of this. So now it kind of looks like there's a belt there. You know what? I'm gonna go crazy because even me, Mr. Colorblind, I like to see that. So let's go to default tray. Show the tray here. That might be on by default for you, and if you don't like it, you can always close this. So let's go to, I think there's a way to do this. Materials. And then colors. Black. There we go. The GT2 belt looks black now, which is good because that's what it is. All right, so now what we can do is let's go ahead and get our camera back because it's kind of starting glitching again. I wish there's a button. If anybody knows how to add a button that switches, that toggles between those two camera perspective and on and off and everything, man, I would love to know about that. So let's move this thing over. Let's see, I'm going to reference. this edge. Uh-oh, I'm stuck inside the aluminum extrusion. Help! Get me out! Alright, click Control, because I want to make a copy here. You know, this could be done with a rotate, couldn't it? No, maybe not. I don't think that's true. So let's go to this tooth right here. And then, of course, this is going to have to be moved up a bit because it's the opposite side. Belt paths are a little bit different there. Okay, so now what we can do is we can rotate this. Click Control. I'm going to rotate this 90 degrees. And we're going to make it unique because it's probably going to be a different length total than those other two. And make it unique is just like, hey, it's going to be a different component. Okay, we started as the same component, but now we have to change it. Let's see. So this, let's see, this is going to be tricky. Man, I apologize. I'm moving the camera around so much it kind of makes you sick, right? That's the problem with this. Let's be lined up here. Oh, that's nice. Just moving around on me. Okay, let's see how this does over here. Not so good. All right, so let's take care of those. Ah, man, that's annoying. Actually, you know what we can do? We just move this one out and just copy it back again. No. Lock it on Y, free it up. Get in here. The problem with this being black is you can't see the lines, which kind of sucks. Again, probably if you're better at this program than me, you know how to do that, but I don't. So. Okay, cool. That should do. Delete. Move this. What is the center to center offset here? 10.71, of course. Whatever that means. Okay, cool. Those are taken care of. Incidentally, I think this would be the same as the belts that go across the x-axis. So we can actually put those in there right now. So I'm going to have to copy these and insert them into this assembly. Paste. Let's reference middle. And that should line up with the exact middle of the printer, which is easy enough to reference here. Yep. And I will need to vertically align them again. Halfway there. And these would go, I'm trying to think. Oh, they go in here. I see. Okay. And let's see how that looks. Hey, awesome. We're on the camera again. Yeah, close enough, I'd say. For what we're doing, that's plenty good. Okay, cool. That's great. And you know what? I'm going to call it, let's take a look here and just take one more look at this thing. Again, this is kind of intended to be a live stream. I'm not editing this at all. I would have live streamed this tonight, but I tried. I got a few minutes into it, and my internet just was not sufficient. I'm missing. Okay, we're not done yet. So I do want to make this. So we're going to move this from this side with the tooth. Copy. Lock on this axis, the red axis. Okay, oops, wrong reference. I'm going to reference this side. Okay, cool, great. And we know that GT2 belt is, especially if you had the teeth on there, it would definitely look more robust than that. We're going to make this thing unique. And you can see that that's actually going through the printed part. This is not a place where this would be. So we're going to go here and push this back. Back, 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 back with the push command. About right here. Okay, cool. So this one. That would be the wrong reference again, of course. Yeah. There you go, love it. Okay, there we go. Midpoint to midpoint. Now I don't have the black filled in for this loop around here or whatever. What's cool too is when you're done with this, if you add in the half circle of belt here, and that's really easy to calculate because a half circle of belt, a half rotation of belt around a 20 tooth will be 20 millimeters, half of that. So that'd be 20, that's 20. This little quarter that's there would be 10. And you can actually precisely, or pretty precisely, or you can get a pretty good estimate at least, I'd say, for how much belt you're going to need for your entire printer if you move things around and adjust it. All right, so again, let me get back and recap what we've done here. We have finished the Y-axis and the upper frame of or the upper assembly for the Hypercube Evolution, and then later we're going to be changing this. Only reason I'm doing this is because later I'm going to modify it, get rid of these aluminum extrusions, and see how I can modify this to be better for CNC production. Because I don't want to use those things. If you want to go back on that, if you want to hear all about that, check out video 1. Hey, thanks for watching. If you stuck in here, you're a soldier. Leave me a comment just to let me know if somebody actually benefited at all from this. Or also leave me a comment if you saw me doing something, you're like, hey man, this guy does not know how to use SketchUp very efficiently. Because I really am, I'm going to be doing this a lot in my, over the years, and it would benefit me greatly to learn how to do it faster. So there we go. The frame, the Y-axis, it's all done. If there's something I forget, we will get back to it in the next video. Thanks everybody.